Hello my dear friends. In the previous lectures, we discussed about the elasticity. We discussed the definition of the elasticity. In that, we discussed how the elastic objects are coming back to its original position, how they are regaining its original size, how they are regaining its original shape, even after the deforming force is present or even after the deforming force is removed. Once after the deforming force is removed, it is regaining its original size, it is regaining its original shape only due to the intermolecular forces which is present between the molecules. And that forces will be known as the restoring force as we studied. And then we studied that we will change the size and shape, that means we will change the dimensions in three ways. First way is that tensile or the compressive method. Like if you are applying the force along its length, then that stress will be known as the longitudinal stress, and it is the first way to deform the object. The second way we studied is that shearing stress. In that we studied that whenever we are applying the force tangential to the area of the cross section, we will observe the change in the shape of the object, or we will observe the change in the position of the object, right? And in the third we studied about volume stress, in which we studied the volume will get changed. The water molecules will exert the pressure on the solid sphere as the pressure is creating around the metal sphere. That means the metal is experiencing force. As that force is helping the metal to shrink, that means that force will be known as a deforming force, as it is helping in changing the volume. You can observe the change in the volume, you can observe the decrease in the volume in the metal sphere due to the force exerted by the water molecules. Now in this lecture, we are going to study about strain. So what is a strain? As you can see here, in the tensile stress, I am applying deforming force from both the ends. So whenever I am applying the deforming force, you can observe the change in the length. It is a change in the length. I am considering it as del x. It is also the change in the length. I am considering it as del x. I am applying forces, as these forces are helping me to change the size of this rod. So I am calling these forces as deforming forces. So whenever I am applying the deforming forces in an elastic objects, a restoring force will get generated exactly opposite to the deforming force. Whenever I am applying the deforming force exactly opposite to the deforming force, a force will get generated which will be known as the restoring force, which will try to bring back the elastic objects to its original size. Yeah, as we studied already in the earlier classes. Yeah, so you can see here, whenever I am applying the force, I am observing the change in my dimensions. I am observing the change in the size here. Dimensions in the sense, you can see the size change or the shape change. Right? So whenever I am observing the size change or the shape change, that means my dimensions are changing. As my dimensions are changing, you can observe here too my size has been changed. The rod of the size has been changed. That means my dimensions are changing. As the dimensions are changing, so the ratio of the change in dimension to its original dimension will be only known as strain. Once again, the ratio of change in dimension to its original dimension is only known as strain. So whenever I am applying the deforming force, I am going to observe the change in the dimensions. So whenever I am taking the ratio of the change in dimensions to its original dimensions, then it will be known as strain. strain. I can take this example. You can see here, what is the change in dimension here? Here the change in dimension is del x. Here the change in dimension is del x. That means it is the change in the length. It is a change in the length. Right? So for this, I can write the strain is equal to change in length del x upon original length, because here the size is changing. Here the size is changing. As the size is changing, you can observe the change in the length. So as I am observing the change in the length, that means I wrote the dimension here, it has length. So change in length upon original length, the ratio of the change in length upon original length is only known as strain. As you can see here, it will be known as the tensile stress, as the restoring force is creating. As the restoring force is creating, whenever I am applying the deforming force, it will be known as tensile stress. So here the tension is getting created. Due to the tension, you can see the elongation in this rod. You can see the change in the length of this rod. You can see the increase in the length of this rod. So this strain will be known as tensile strain. This strain will be known as tensile strain, which will be known as change in length upon original length. As we see in the previous classes, whenever I will compress this rod, what will happen? The rod size will get reduced. As the rod size is getting reduced, that means we can observe here too the change in the length. Here too I am observing the change in the length. The length has been reduced right now. So you can see the change in the size. That means for the compressional strain, the formula is going to be the same, which is known as the change in length upon original length, or you can say the ratio of the change in length upon original length. As we studied the tensile strain, the tensile stress and the compressive stress comes under longitudinal stress, as the force are acting along its length. So as it is, here too the tensile strain and compressive strain will comes under longitudinal strain. Longitudinal strain. And what's the formula for the longitudinal strain, or what the definition for the longitudinal strain is? Nothing but the same. The ratio of the change in length to its original length is only known as longitudinal strain. Change in length upon original length. So it is about our first type of strain, which is known as longitudinal strain, and it is a strain definition. What is a strain definition? If we are observing the change in dimension, then whenever we will take the ratio of the change in dimension upon its original dimension, we will get the strain. Okay? Yeah. Now we are going to see the second type of the strain, which will be known as volume strain. You can see here, in the volume strain, we study the volume stress as the water molecules are present. Inside these water molecules, a metallic sphere is there. This metallic sphere is experiencing force due to these water molecules, because these water molecules is exerting pressure. On this metal ball. As the water molecules is exerting pressure on this metallic sphere, so this sphere is getting experience a force. Due to that force, this metal is getting shrink. So you can see here, the volume of the metal has been changed right now. That means it is a change in the volume. So you can see here the dimensions of this sphere has been changed. As you know already, whenever the force is getting experienced by this metallic sphere, inside the metallic sphere a force will get generated, which will be known as the restoring force. And if this deforming forces will be removed, if this water molecule forces will be removed, That means it will be taken out, it will regain its original size and original shape. That means it will regain its original volume here. Right? Once after that, deforming force is removed. Just because due to the restoring force which is getting generated because of deforming forces inside the object. So you can see here, that will be known as the volume stress. Here, as I am able to see the change in the dimension, change in the volume right now here, it will be known as the volume strain. It will be known as volume strain. So, volume strain, you can say very easily, the change in volume, it is the ratio of change in volume to its original volume. To its original volume. Let the original volume be V and the change in volume be del V. That means del V upon V. So whenever I am observing the change in the volume, then change in volume upon original volume will be known as volume strain. The ratio of the change in volume to its original volume will be known as volume strain. It is a second type of strain. Now we are going to study about third type of strain. So as we studied three types of stress, the same three types of strain is here. So whenever a stress is experienced by an object, that means whenever we are applying the deforming force to deform the object, we can apply the deforming force in three ways. In order to change the size, in order to change the shape, in order to change the volume. Right? So we are doing the same. If I am changing the volume, I am saying it as volume stress by applying the deforming force. If I am applying the deforming force to change the size, I am saying the longitudinal stress. And whatever the change I am experiencing, that will be known as the longitudinal strain. If I am changing the shape, by applying the deforming force, it will be known as a stress. What stress? Tangential stress or shearing stress, in which you will be seeing the relative displacement. As you can see the relative displacement there, so relative displacement upon to its original length will be known as this shearing strain, the third type of strain which I am going to take right now. You can see here, what the third type is that, what I have done is that I have taken the cylinder. What I done in the previous class, the same example is that here. And the cylinder is fixed right now. I am just applying the deforming force tangentially to this area of cross section. Whenever I am applying the tangential force, the position of the cylinder is getting changed. It is the length L. So you can see the position of the cylinder has been getting changed right now. So you can see initially the cylinder is here. So it is the relative displacement which happened just due to my deforming force. As I am observing the relative displacement, so the ratio of relative displacement to its length, will be known as shearing strain. So shearing strain, whenever I am applying the deforming force, I am observing the relative displacement. So the ratio of the relative displacement upon its length will be known as shearing strain. If I am considering this as theta, if I am considering it is making an angle theta, then tan theta is equal to opposite side by adjacent, which is known as delta x by L. You can see here delta x upon L. That means relative displacement upon length. I can write this tan theta is equal to del x by L. If this theta is less than 10%, if theta is very small, then tan theta will become theta. Then tan theta I'm writing here, you can see here. I'm writing here, see. So once the tan theta will become theta, theta is equal to tan theta when theta is very small. Very small. So theta is equal to del x upon L. Right? So it is about the shearing strain. You can listen here. So we studied about the types of stress, we studied about the types of strain, and we studied how the molecules are getting interacted and how the intermolecular forces are getting generated, and we studied in the first lecture about the elasticity. Right? In the next lecture we will study about Hooke's law. If you like this lecture, comment it. If you have any queries, you can ask me in the comment section. It will be clear as soon as possible. Yeah, if you like this lecture, you comment it, subscribe it, and share it to your friends. Have a good day. Take care.